Now, we will give a brief overview about the most popular and successful techniques covers in modern speech synthesis that mostly using computer algorithms instead of mechanical or electrical methods. This session will introduce the early used technique, articulatory synthesis, and the classical technique, ferment synthesis. Articulatory synthesis method models movements of articulators and acoustics of vocal tract. Ferment synthesis starts with acoustics and creates rules or filters to create each ferment. Catenative synthesis uses databases of stored speech to assemble new utterances. HMM-based synthesis runs a statistical HM model in generation mode. Lately, deep neural network has been tried in TTS. Each technology has strength and weakness, and intended use of a synthesis system will typically determine which approach is used. Articulatory synthesis refers to computational techniques for synthesizing speech based on models for the human vocal tract and the articulation processes occurring there. The shape of the vocal tract can be controlled in a number of ways, which usually involves modifying the position of the speech articulators, such as the tongue, jaw, and lips. Speech is created by digitally simulating the flow of air through the representation of the vocal tract. This method is complicated and the synthesized sound quality is not ideal. Some early attempts with articulatory synthesis can be listened in the sound example.
She saw the house. This is the test.
Ferment synthesis does not use human speech samples at runtime. Instead, the synthesized speech output is created using additive synthesis and an acoustic model, physical modeling synthesis. Parameters such as fundamental frequency, voicing, and noise levels are varied over time to create a waveform of artificial speech. This method is sometimes called rule-based synthesis, in which duration, pitch, and energy rules are applied. Ferment synthesis combines multiple ferment filters to simulate the transmission characteristics of the vocal tract and modulate the excitation source signal. Finally, obtain synthesized speech through radiation. Many systems based on ferment synthesis technology generate artificial, robotic-sounding speech that would never be mistaken for human speech. There are three types of ferment synthesizers: cascade ferment synthesizer, parallel ferment synthesizer, and hybrid ferment synthesizer. In the cascade model, the vocal tract is described by a set of second-order resonators connected in series, and the ferment filters are connected end-to-end. Its transfer function is the result of multiplying the transfer function of each ferment. The figure shows a cascade ferment synthesizer, OVE, built by the Swedish phonetician Gunnar Fent in the 1960s. Weeks and weeks of tuning each system could get much better results. Here are several sound examples we could hear and compare.
How are you? I love you.
Welcome to the Stockholm Speech Communication Seminar.
Welcome to the Stockholm Speech Communication Seminar.
In the parallel model, the input signal is adjusted in amplitude first, and then added to each format filter. Finally, the output of each channel is superimposed. Experiments show that 3 formats are good enough for intelligible speech. There is a sound example to show the result of 3 format synthesizers.
What did you say before that?
In the year 1950s and 1960s, people debated whether parallel or cascade synthesizers was better. The rivalry between the cascade and the parallel methods continued into the 1970s. Cascade synthesizers were good at producing vowels and required fewer control parameters, but were bad with nasals, stops, and fricatives. Parallel synthesizers were better with nasals and fricatives, but not as good with vowels. Dennis Kleck proposed the synthesis and combined the 2 forms. Glad Talk, that is 1979 MIT Talk, has since become the standard for format synthesizer. Later, in the year 1983, DEC Talk system was developed based on the work of Dennis Kleck and then generated the voice of Stephen Hawking. Dennis Kleck invented a hybrid format synthesizer which combines the schemes of cascade and parallel synthesizers. He also made significant improvements to the artificial voice source waveform. There are 3 types of excitation sources in the hybrid format model: periodic impulse sequence when synthesizing voice speech, pseudo-random noise when synthesizing unvoiced speech, and periodic impulse modulated noise when synthesizing voiced fricative speech. For synthesis of arbitrary text, formats and bandwidths for each phoneme are determined by analyzing speech over a single person. The models of each phoneme may be a single set of format frequencies and bandwidths for a canonical phoneme at a single point in time, or a trajectory for frequencies, bandwidths, and source models over time. The format frequencies for each phoneme are combined over time using a model or co-articulation. Here, we could listen to synthesize the result of the early DC Talk system, something like this.
Text-to-speech systems are beginning to be applied in many ways, including aids for the handicapped, medical aids, and teaching devices. The first kind of aid to be considered is a talking aid for the vocally handicapped. According to the American Speech and Hearing Association, there are over 1 million people in the United States who are unable to speak for one reason or another.
Instead of specifying mouth shapes, format synthesis specifies frequencies and bandwidth of resonators, which are used to filter a source waveform. Format frequency analysis is difficult. Bandwidth estimation is even more difficult. But the biggest perceptual problem in format synthesizer is not in the resonances, but in the basic quality, most likely due to the glottal source model. Format synthesis can sound identical to natural utterance if details of the glottal source and formants are well modeled. Another method of format synthesis developed in the year 1970s is known as linear predictive coding, LPC. This method uses LPC-derived filter in conjunction with a voice source to create a synthesized speech. It is a kind of a source filter model. The excitation signal composed a white noise sequence and a periodic pulse sequence. After gating, amplifying, and passing the time-varying digital filter, the speech signal can be obtained. LPC synthesizers greatly reduces the amount of information in speech.
Now spell one as in one word. O-N-E, rep. Next, spell earth.
There are two forms of linear prediction synthesis. One is a recursive synthesis filter, constructed directly with predictor coefficients. In this way, the excitation parameters and prediction coefficients are periodically changed to synthesized speech. Another one is a lattice synthesis filter, which is composed of reflection coefficient and the backward prediction error. Firstly, LPC speech synthesis has relatively simple and fully automatic analysis steps, and the structure of the synthesizer is relatively simple. When the lattice filter is used, the quantization characters and stability are better, and the hardware implementation is easy. While format synthesizers requires more parameter adjustment, synthesizer structure is relatively more complicated. Secondly, the principle of format synthesis is closely related to the principle of actual vocalization, and its model control parameters have a relatively intuitive influence on the spectral characteristics of synthesized speech. In LPC synthesis, the change trajectory of controlling LPC coefficient is very limited. Third, format speech synthesis is more flexible, allowing simple transformation to imitate the pronunciation of different people. By moving the format frequency, it is easy to change the part of speech that is related to the speaker's characteristics. LPC synthesis is more difficult. It is possible to make similar corrections only when the reflection coefficient is transformed into the position of the pole. Fourth, in the linear prediction method, modeling of the spectral envelope valley points is much worse than the peak point. So, the estimation of the format bandwidth is generally inappropriate. In the format synthesis method, the bandwidth of the format can also be estimated from the discrete Fourier transform spectrum. Fifth, the owl-pole model of standard LPC has poor effect on this sound with 0-point spectrum characteristics. especially nasal sounds. The format synthesis method can use anti-resonators to directly simulate the most important spectral zeros in nasal sounds, improving the synthesis sound quality. Generally speaking, the choice of LPC speech synthesis or format synthesis is based on a comprise of two factors. LPC synthesis has the advantages of simplicity and automatic coefficient analysis, and a more complex format synthesis is expected to produce high-quality synthesized speech. That's all for this session. See you next session.